Welcome back again. We want to continue from where we stopped. So we want to perform our Procrustes and ANOVA. So before we do that, though we need to visualize this in color to see how it is done. But before we do that, come back to that. Let's first categorize our landmark data. So to do that, we are going to extract. Okay, we are going to do extraction of a classifier. So here we click on displays. Preliminaries, and we click on extract new classifier from id string. So now don't forget our IDs. Okay, the first thing we do, we separate ID from all of them first. These are the identifier string, but we want to select this 1 2 3 1 2 3 for the first, second, and third represent our ID. So we now say 1 to 3. Okay, so count 1 2 3 for all data. So you extract that out, you click on execute, you go back again, extract. We want to extract sex. That's our male and female. So the first character denotes our sex, which is F for female and M for female, M for male. So we now say 1. So we are within the 1 first. So we execute again. So we go back again, we generate another one, extract. Now we are going to do for error now, for digitizing error. So if you scroll down, you understand that we have all those CC added to it. So in this, then we have 1 2 3, so which means 4 5, which means we go to extract 4 and 5 now. So we now come here, we now say 4 to 5. So we want to extract this out for us. Click on execute for error. So now we have done this. So I can now go back to the place now and say edit classifier. You can see them here. These are our ID, our sex, our error. So when you scroll down, you see that the ID is 3. There are 3 number, 3 characters, and sex only 1. Both only M, male and female. Okay, and error is only CC here. Okay, so this is very important. You need to know how to do this. This will give you the accurate result, else you have a lot of problem in accounting for your analysis and your error assessment. Now we can click on sex and change this. You can see it's highlighted. Change this value of M to female, male and female. In case you don't want to use M and F, you can come to replace value here, replace values for wherever there is F, change it to female. All right, so replace all. Okay, go back again. Where there is M, replace to male. Okay, replace all. Done. So now we have sex for male and female now. All right. So when we have visualized our data, it will be more clear to represent our F with female, our M with male. So instead of just F and M. All right. So now let us accept this now. We accept it now. So we can come back to the score and right click on the score now and see color data points. Okay, the color data points. Now we can see that we can now have a sex here to represent our data. So I don't want this color, I want to replace this color with a blue. Use blue for this. So when you're done, so I want to use for female red, male blue. You can change your color here if you don't want. You can select if you don't want to use red for blue for female, you can choose another color here. There are many colors here you can choose from. You can mix color if you want. All right, depend on what color you want. So now I can click on OK. You can see that this is my principal component analysis now. Principal components now. You can see the variation, the distribution of the specimen on the morpho space. You can see how they are distributed. You can see female concentrate in this region, while male in this region as well, though some scattered around. You can increase the size, the data point size. This is 5.0. You can make it maybe 7 or 8. Click on OK, so it become more bigger. All right, so this can be exported. Okay, I export this out to graphics, and you can now put in your manuscript. All right, so this is what we call principal component. So you can do it in various ways. So if you have because we have only male and female, if you have many more than that, everything will show here as well. So right, So this is the shape, okay, don't forget the shape, how it should look like. So now we want to perform our Procrustes ANOVA now. Okay, we want to see how to compute error assessment to see how small our error is. So now the first thing, the thing we do now is that because we have done this, we have extract a classifier from the string. So now we can now go to variation now and click on Procrustes ANOVA to compute our error assessment. Now, with a data set is already selected, if you have more than one data set, we choose from here. Our data is 3 dB. Now, this an identifier, an individual is very important. That's why we first created it first. We have ID, which we created during our extraction. You select that. You leave this side alone. It's not needed because we are not dealing with side. Then for the first error, it's talking about the digitizing error, and second error is talking about imaging error. So because we are not dealing with imaging now, though they follow the same sequence, which I have explained before about imaging error, but now we are dealing with a landmark digitizing error. So you click on this, select a error here. All right. So this is our error for digitizing. Then we click on sex. This is our general effect. So you now click on execute here. So don't forget this arrangement is very important. The individual must be ID. Okay, error must be the error you extracted, which we computed in our Excel sheet, and we now select sex here. If you don't want sex, you don't want to look into this or effect, you can let it. You can click on none. But because we want to account for the sex also during our error assessment, you can also select it. So let's execute and see what I'm talking about. So you scroll down now. It won't be showing in the graphics form, okay? It won't show here. It's only show in the result. So don't forget that because we don't usually need it in that place. We need it in the result. So this is our PCA, okay? Our principal component we have generated. All right. So we have how many pieces? We have how many total of 65 pieces. All right. So let's go to our Procrustes ANOVA. You can see now this is our Procrustes ANOVA. This is our error assessment data. Now we don't want to account for central size. Okay, we leave central size out of it. So if your hypothesis requires that, fine, you can account for central size also. But because we are only looking at a shape Procrustes ANOVA for now, so let us look at this. Don't forget this particular region is very important. It gives you the representation of those variables. Extra one means sex, individual ID, error 1 means error. So now if you anywhere you see extra 1, it means sex. So now we are looking at extra 1 here, which means this one means sex. That's what it means. All right, this individual means ID, and error means digitizing error, which is our error data. So our error here is 0.027. okay, you can see it's very small, very small, 0.027, which means we have a very small error. So you can let go of the residual. I don't want to compute it. You can let go of this. Okay, you can let go of this. So this can be copied into Excel sheet and compute. I know you have been seeing something like this many times. You don't know how to perform it, but now you can see. Also, you can see under extra 1, the error for sex is 0.02, which is significant, and for error is also significant, but for the individual it's not significant. All right, so you can compute this. Now we can copy this out and paste it in our Excel, but Morphometric will not allow you to just paste like that. You have to mostly copy and enter into Excel one after the other, because you will not be able to paste like this. Okay, it's just in normal text file. So we can do this and put in our Excel sheet. Okay, if you open our landmark data here or error here, you can open another sheet here and copy this guy. You say export to file, you want to export all, so which I don't need. All right, I don't need all, I only need this. So let's just copy only this. Just say Control C to copy instead of exporting all. All right, so let me paste here. Let me see how it look like. You can see here now. Okay. Can we separate this? Let us see how possible it will be to separate this. So which means we need to copy this and paste one after the other. So I don't. So now you can do that because we need to account for individual error. So now let's copy this and paste in our Excel one after the other. Let's first create the column. Here we have this. I want to put something else here. That's why I left this place like that. I want to put something else here as a variance, percentage variance. So you fetch let's do like this. Okay, so let's do this. Now we have effect the extra one. Let's start from individual first. Okay, individual. Copy this. Paste here. Okay, then you copy this sex. You put sex here. Then error. So returning error. Put here. Then here we can have total. Alright, so let's copy this. Start from individual. You can start from anyone, but I think you just want to arrange it. So this SS here, I copy this and paste here. And this one I copy this. Paste here. Okay. Then this one's 52. F is 0.96. So you can just do this for all of them. All right. Sorry, I was formally I was copying central size before I realized that it was wrong. So I've corrected myself. So now we have this this one copied here now. So here I want to find the total here, total of everything here. Then I can now compute my percentage variance. So now I click here, I compute total. All right. So maximize. Go to the home, auto sum. Okay. Same thing for this. Auto sum. This will not necessary, but let's also. So now we have auto sum for this and this, so we can put this. So this is the total sum. Now we want to account for the percentage of all each of them. So now this one will be, this is individual now. So we want to look at C2. This is C2 now, divided by total, which is because we are looking at sum of square error divided by total, which is a C5 times 100%. So let's say equals to C2 divided by C5 times 100. Okay, this is 84%. So also the same thing, C3, C equals to C3. Don't drag down, so it won't give you a correct answer. So this is 5 divided by times 100. Also here we have equals to C4 divided by C5 times 100. So here the total should be 100 here. If you sum this one, it should be 100. So let's sum. Okay, this 100, that's correct. So now we can copy this now and put in our manuscript. So this means that an individual account for variability of 84%, which one says 5.19% and the digitalization error is 10.33%. All right, so you can see that this one can be analyzed later. All right, so this is how you compute your error. The error is small, it's small enough. Okay, it's small enough, 0.02. Though we have left out something which is residual, which is not accounted here, so you can include that in your own. Okay, you can include residual in your own if you want, but I just excluded that here, so you can do that because that has affected the total error here for this particular digitization error. So it could have been more smaller than this, I mean in percentage, but because we excluded the residual, that's why it's like that. So in your own case, you may include residual and account for it later. So this is how to account for Procrustes ANOVA error assessment. All right. So you can export anyone you want to use in your data out and see how it look like. So I will see you in the next lecture. Thank you so much for listening.